and then I'll type in the 4. So you got this one that's just a plug and a chug. There it is. Math over to prob down to number 8. All right, the next one, it gives you these two things. Now, you may not remember what that symbol is, but up here it says, can't see it, find the mean. Find the mean. Okay, so, yes. So if you're having a blackout moment, you're like, okay, I find the mean by doing one of our stats in my calculator. And there's two sets of data. So I would do L1, L2. So I would do stat edit, I would do my L1, I would do my L2, and then I would do stat calc, one var stats. Now here's what's going to get you. You've got to do the L1, L2. So I'm not going to put in the actual data, but I'm going to do stat edit. I've got in some L1. I've got to do something to get all my data equal or it's going to yell at me. Okay, my data's equal, so I'm going to do stat calc, one var stats. Now, if you just do L1, it's going to give you an answer, but it's just going to give you the mean of list 1. So you've got to do L1 and then do your L2 to tell it that it needs to look at both lists. If you don't do that, you are not going to get the right answer, and you're going to say, but my calculator said. Your calculator is only going to be as good as the person who uses it. Now, remember the other calculator, you're going to do one var stats, and it's going to be L1, comma, L2. But you just got to make sure you do both of those. All right. They want to know, are these probability distributions? In order to be probability distributions, these have to be numbers. These have to be between 0 and 1. And these have to add up to 1. And I did several of those. That one is a yes, this one is a yes, and this one is a yes. But all I'm looking to say is, are they numbers, are they between 0 and 1, and do they add up to 1? Now, they may add up to 0.998. Because of rounding, I still say yes, because it's super, super close. All right, now, find the shaded area. I'm finding this. What am I going to use? I'm going to use the normal CDF. Now, because this says standard normal, what is my mean going to equal? And what is my standard deviation going to equal? Okay, for normal CDF, we do left, right, mean, and standard deviation. What is my left? Negative 1.82. What is my right? What is my right? 999. What is my mean? And my standard deviation? 1. Okay, got it right there, and I got the answer.
They should put that 182 there.
Okay, this is the same thing. Find the area of the shaded. You would do your left, you would do your right. It is a standard normal, so your mean is 0 and your standard deviation is 1. We'll go through these quick. I've got them written down so that you can see them. And I've got the answer there. This one is going to be negative 999 to 0.66 with a 0 and a 1. We good? Negative 999 to 0, 0.66 with a 0 and a 1. This one is going to be negative 1.99 to 999 with a 0 and a 1. These are all the same kind of problem. You're only going to have one on your test. I did it to the left, I did it to the right, I did it in the middle. I'm going to come back to that one in just a second. That one's going to give you a fit. This one is talking about z-score again. This is saying if you have a normal distribution with a mean of 171.55 and a standard deviation of 8.35, and you have a short mean and you have a tall mean, what is the z-score? So we do data minus mean over standard deviation. Z equals data minus mean over standard deviation. This is the short guy, and this is the tall guy. So let me color coordinate. This is my short guy. This is my tall guy. So when I did the short guy, it was data minus mean over standard deviation. And the tall guy was data minus mean over standard deviation. So my short guy is 15 jumps to the left. My tall guy is 10 jumps to the right. So it says this one is 15 jumps to the left, this one is 10 jumps to the right. So which man was more extreme? The short guy, because he's 15 jumps away, where the other guy's 10 jumps away. P of 60 means what percentage?
60.
So P60 means 60%, but we're going to use .60. For this one, it says find the score, which means we're trying to find that. So we're doing the inverse norm. We do the area under the curve, which is the P of 60, which is the 60%. They told me the mean was 200 and the standard deviation was 50. Area, mean, standard deviation. This is the same as the short man, tall man. This is the same as the short man, tall man. Trying to touch everything before we get out of here. This one is trying to find that point. We do the inverse norm. So it's area, mean, standard deviation. It is standard. So your mean is 0 and your standard deviation is 1. This is to the right.
1 minus.
We do 1 minus. Create a pen, star, star, star. We do 1 minus the area because it's to the right. Not Beyonce. Okay. These are not, this one says, draw a graph to find the density that corresponds to the lowest 11% and the highest 11%. Lowest 11, highest 11. You can just look at it. If it would have said middle, if it would have said less than this or greater than this, so you can go by the wording to get that one. This one you are finding a point. That's why we're doing the inverse. This is to the right. So that's why we're doing 1 minus. It's not Beyonce.
We would only do that on inverse norm, right?
Only on inverse norm. Only inverse norm to the right is 1 minus the area. This says P of 83, so that means 83% is shaded. And our shading always starts from the least to the greatest. So this is from the greatest to the least. This is working backwards. Y'all, that isn't 83% because that isn't even 50%. That isn't 83% because that isn't even 50%. So percentage always goes from the left to the right, from the least to the greatest. All right. 17, P of 17, 17%, always goes from the left to the right. 17% is less than 50%. Rejects the bottom 2% and the top 2%, so that's going to be the bottom and the top 2%.
What?
They reject them if they're too high and reject them if they're too low. So you're rejecting the top two.
Oh, okay.
Here you're just rejecting the high two, and here you're just rejecting the bottom low, and here you're rejecting the middle ones. Now, this one is that central limit theorem that we did. This said one candy. You're finding the shading, so it was normal. You did the left, you did the right, you did the mean, you did the standard deviation. Here, part B said you had a group of 459 candies. So it was group data. So everything was the same. The left, the right, the mean. The only difference is you take your standard deviation and divide it by the square root of 459. Remember? Okay. The next one, you're finding 2 points this time. In between 120 and 161. You're finding the shading, so we do the normal. 120 to 161, your mean, your standard deviation. That was for his weight, one person. The next problem says a group of 40. So you do the same numbers, except you divide by the square root of 40 because it's 40 people in the picture. There's another one, single piece of data, 64. That and that are exactly the same thing, except I did divide it by 64. This is just regular. If a college, that's one piece of data. So it's going to be a normal of the left and the right and the mean and the standard deviation. That is for A, that's single data. Oh, no it isn't, because it says 40 mechanics. That's why you're dividing it by the square root of 40. This is the one that says, okay, this is my mean, and I'm going to wiggle off my mean. I'm going to add 2.1 and I'm going to subtract 2.1. Here's my mean, 24. I'm going to add and I'm going to subtract. And then the last one's the same thing. 82, I'm going to add it and I'm going to subtract it. 1 minute to spare.
Do that one problem.
Oh, crap.
Can you do that last one?
Yes. This one ain't going to be on there. Don't worry about that one.
Okay, good.
That one's not going to be on there. Yeah, I looked at it's in the homework to talk to you about significantly high and significantly low, but that one's not going to be on the exam. Don't worry about it. Do which one?
The statistic in the margin error, the very back page.
This one?
Yeah.
Okay, so confidence interval is when, you can leave if y'all need to. Exam a week from today. Do I need to reopen the homework?
Oh, wait, no, never mind. I was wondering.
To
what-
go the other way?
Yeah.
That's not on the exam, to go the other way.
Oh, okay.
If I give you the confidence interval and go backwards, it's not on the exam. Do I need to reopen homework? Reopen homework? When do we want to make it due? Your exam is, I'll make it due Monday night. That way I'm giving you a few days to not worry about homework and to worry about the exam. Your exam is Thursday, a week from today, at 9:30 in this room. Monday night. Brittany, come here for just a second. Let me know if you have questions. I will post this in the homework. Not in the homework. Y'all know what I mean. Hold on, I thought I had something for you. But I don't.